This video is working through the 2017 Northern Hemisphere Further Maths Exam 2, looking at matrices. So question 1. People pay to attend a concert at the White Oak Theatre. They can choose their seats for each concert from the 3 classes, A, B or C. The table shows the number of seats available in each class and the cost per seat. We've got our information here. Part A is asking, the column matrix N contains the number of seats in each class. What is the order of matrix N? So remember, order is talking about the size of the matrix, and we report that in terms of the number of rows. So we have 3 rows in this matrix and 1 column. That's always in the order rows by columns. Moving on to B. Matrix W contains the cost of each class of seat in the theatre. Part 1, determine the matrix product Wn. So we're doing matrix W, 45, 35, 30, times matrix N, 100, 340, 160. And so obviously we're going to utilise our calculator to do that. So let's pop across now. Okay, so entering those into our calculator, we're going to utilise the little template for matrices. W was a 1 by 3 matrix, and so entering those values, and then again N was a 3 by 1, and entering those values, and we get a 1 by 1 matrix because our order there, we've got 1 row in the first matrix, 1 column in the second, and so we get 21,200. And so remembering to put our answer in matrix form, and so that's our answer for part A, part 1. Part 2, explain what the product matrix Wn represents. So we have to give an explanation of what our previous answer, what that number represents. So when we're doing multiplication, not only do we need to consider the order of our matrices we're multiplying, but we can also consider the labels. So if we look at matrix W, what it was representing here was the cost. So effectively, we were talking about cost as our row label times each seat number. So if we think about, we've got cost by seat in our rows and column headings, and then we were multiplying that by matrix N, which matrix N had the seat types or this class as the row headers, and the column heading or column label was the number in each class. So we had seat by number. And so what our product matrix, along with being the size of those outside values, that will actually give us the label for our answer. So our answer matrix from part 1 was actually saying we've got cost or the number of seats. Okay, so what it is actually saying is that our explanation here is that Wn represents the total cost of all seats, and that was 21,200. Let's see. The number of seats that were sold for the first concert this year is shown in the table below. This information is then used to construct the matrix P shown below. Matrix P contains the value of all seats in each class that were sold for the first concert this year. So we can see, if we just pause here, we can see this diagonal matrix, the first one, when we actually multiply this out, because as we multiply, we work across our row and down our column, we're saying 42 times 45, so 42 seats at $45, which is 1,890, then plus 0 times 35 and 0 times 30. So it's only giving us that, total value of those A-class seats sold, so 1890. In our second row, so as we work across second row, first column, we're now getting the value that will sit in row 2, column 1 of the answer. And again, it's got 0 times the A-class tickets, but 179 times the B-class. So that would give us 6,265 as the value there. And then finally, if we look at row 3, and again, we're working down column 1 to give us the value that goes in row 3, column 1 of our answer. We've got 0 times 45, 0 times 35, and 86 times 30. So it's giving us those values, that sum. And that one is 2,580. So matrix P itself is actually, when we evaluate that multiplication, it's a column matrix, which is showing us the total revenue or the total amount made by selling the seats at the cost given in the table above. And so that's a special use of a diagonal matrix there. If we continue now on with the question, we're then asked, a matrix product, MP, is found where M is equal to this matrix here. Now that looks very much like a summing matrix because it's a single row. However, the difference here, which we normally don't see, is there is a 0 in that first element in row 1, column 1. So here, when we actually do M times P, we are going to get a sum of this P matrix that we've evaluated above. We're going to do 0 times the A class, plus 1 times the B class, plus 1 times the C class. So what we're actually getting there is that 6,265 plus 2,580, which is 8,845, which is the total revenue made just from the seats in Class B and Class C. So they've done all of this sort of background prep work that they're expecting you to be able to interpret before now you can answer the question, which is explain what does it represent. So when you're given a question where it says to explain something that you haven't actually calculated, you should go ahead and calculate it. So put all of those things into your calculator and see what does the answer come out as. And then can you step your way backwards to work through logically as to what it represents so that you can give an answer. So for our answer here, explain what the matrix product MP represents. It represents the total revenue from the Class B and Class C tickets. Question 2. The White Oak Theatre Club has 200 members who buy tickets for every concert. The members can choose seats from each of the 3 different classes, A, B, or C. For each concert, the choice of seat class for these members can be determined using a transition matrix T shown below. So we do see that people can change. In part A, an incomplete transition diagram for this matrix T is shown below. We're asked to complete the transition diagram above by adding on all of the missing information. So remember, your transition diagrams where there is movement between every location should always look the same. So what we are missing at the moment is movement from Class C to Class B. And so we can see from C to B, we've got 65%. or 0.65, and we need to add a direction on that arrow there. We're missing a direction for class A connecting to class C, but we can see that the proportion is 0.05. So in our matrix, we can see that C to A is 0.05. So we need to add a direction here going from C to class A. Finally, there appears to be an edge missing between now A to C. But if we look at our transition diagram, A to C, we can see that value is 0. So we could draw an edge on, and it would not be incorrect to have an edge drawn with the arrow with a 0 there. Okay, but because it is no movement in that direction, you do not need to represent it. Okay, but it would not be incorrect. The two things we are looking for, though, is the edge from C to B and the direction on that arrow, C to A. Part B, the number of seats in each class chosen by the members for the final concert this year is shown in matrix S0 below. So we have our initial state. What percentage of these members chose class A? So here we can read from the matrix there are 16 members, but remember it's asking for percentage. So 16 out of the 200 members and times by 100 to make a percentage means we have 8% of the members. Why I knew it was 200? Two ways. I can either add up all of the members here in that initial matrix because everyone is accounted for, or alternatively, back at the beginning, they gave me that information. Okay, so you will always have access to that information if you need it, either by reading what is stated in the question or knowing that you can add the initial state matrix together. For the first concert next year, some members will choose a different seat class from the seat class that they chose for the final concert this year. So part C, what percentage of the 200 members are expected to change from class B to class A for the first concert? So we're just referring back to our transition diagram and seeing what is the change from B to A of those 200 members. So we can either go back to the diagram or the matrix itself, and we're going from B to A, so 25%. Or we can see again that movement on our diagram. So our answer here for C, 25%. The expected number of these members and their choice of seat class for the nth concert next year can be determined using the recurrence relation. So we have our recurrence relation, very standard form here. Write down the state matrix S1 for the expected number of members and their choice of seat for the first concert next year, and write your answer correct to 1 decimal place. So in order to get S1, that means in our calculator, we're going to do our transition matrix times S0. And so in our calculator, I'm going to put in our matrix. Our transition is a 3 by 3, and just entering in our values as we can see them on the page. And multiplying that by our initial state, which is a 3 by 1 matrix. We have 16, 96, and 88. And so that gives us our S1 matrix there to 1 decimal place. Part E, in the long term, how many members would be expected to buy B class seats for a concert? So remember, when we say long term, that's when we're talking about steady state. And so we're going to utilize our calculator to find that steady state. So going back into our calc, I am going to copy down what I had before with my transition matrix And because I just want to jump to absolute steady state, I'm going to do to the power of 100. And so here I can see I will end up with 85.7, so 86 people choosing class A, 100 people choosing class B, and 14 people choosing class C. So I can jump straight back into here and say, well, in the long term, class B, there will be 100 members. Part F, it is expected that from the beginning of the third concert next year, the White Oak Theatre Club will have more new members. 10 new members are expected at every concert. For the first concert, new members will not be given a choice of seat. So matrix K2 represents or contains the expected number of members in each class of seat for the second concert next year. So that's just following on from what we would have had in the scenario above. The expected number of members in each of the seat classes for the third and fourth concerts next year can be determined by this recurrence relation here. So K3 will be our transition matrix times K2, which we've been given here, plus B. And B represents our new members. And you can see 2 people will go into class A, 7 into class B, 1 into class C, total of 10 new members. So determine the number of members who are expected to choose class A seats for the fourth concert next year, and rounding our answer to the nearest whole number. Okay, so here in this style, we must use recurrence relations to allow us to go from K2 that we've been given. So we need to do this calculation to get K3, and then we take our K3 answer and we use it to get K4. So in our calculator, we first need to put in our initial K2 value. So going in, K2 was a 3 by 1 column with values 61, 116, and 23. So we press enter. Now we're going to use that as the answer, and I'm going to type the recurrence relation as I see it. So my transition, I'm going to cheat and copy from above. Transition times my previous answer. I'm going to pick up answer, and plus my B matrix, which is the new members. So I have to enter that one in because that's a new piece of information. We had 2, 7, 1, and press enter. So that was going from K2 to K3. So I now have K3 here. When I press enter again, you'll see it picked up that previous answer and substituted it in, but my transition and my matrix B stayed the same. So now I've subbed in K3 to give me K4's answer. So this is the fourth concert here. So I've got 84 people in seat class A. I've got 117 in seat class B and 18 people in seat class C. So I'm going back to my answer here. It's asking for seat class A, and I can say K4 was 84, 117, and 18. Therefore, I had 84 members in class A. That's it for this module, for this exam. Hope that was useful.